Hello, everyone. Thank you for joining us. I hope you all are doing well. We're back with another amazing session today during this ongoing Global Pakistan Tech Summit. I would like to give a quick introduction about myself. My name is Hamza Tahir. I'm the chapter director of Slack Platform Community in Startup Grind Islamabad. At Slack Platform Community, we host monthly events on topics involving startups, technology, checking out new platform releases at Slack, talk about what we've built, and learn from each other. Slack as platform community is a global community having a presence into 80 plus cities around the world, including Lahore, Karachi, Islamabad as well. Together with the support of AWS, we're super excited to be hosting this fantastic session on serverless for startups and developers with Donnie Prakoso today. Thank you, Donnie, for honoring us with your presence. I would like to give the introduction of Donnie. Donnie is a software engineer, self proclaimed barista, cafe racer enthusiast, and senior developer advocate at AWS. With more than 16 years of experience in the technology industry, from telecommunications, banking to startups, he is now focusing on helping the developers to understand variety of technology to transform their ideas into execution. He loves coffee and any discussion on topics from microservices to AI and ML. So let's proceed to today's session. Over to you, Dhoni.
Thank you, Hamza. Hello, everyone. Hope you're doing well and safe. And thank you for joining me in this session. So today we're going to discuss about serverless computing. And when I structured this session, it's actually a collection of my experience on building stuff with serverless for almost like 6 years. So I've been building like a quite number of high-scale systems like ad serving, SMS gateway, APIs, and also content management system. And up until now, I'm still amazed on how utilizing serverless is greatly improve our agility and removing many obstacles while doing development, and yet still providing a scalable systems, highly available with less of maintenance and also operations. So that's a quick overview. And my hope is that this talk is going to give you developers and especially from startups and an insight to get going with the serverless development and to help you accelerate and market your products faster. So that's why I'm super excited. And thank you, PacTech organizer, for organizing this. So moving on, just want to do a quick introduction of myself. My name is Donnie Prakoso. I am senior developer advocate for AWS, and I'm covering ASEAN region. I have like 16 years plus in software development and also system operations, ranging from banking industry, telco to startups. So I've been into like a lot of companies, and I was so lucky to be in the part of like an evolving technology across my working experience. I started from a software developer to R&D manager to CDO, and I'm specialized in microservices, event-driven architecture, and also machine learning, especially reinforcement learning. So if you have any questions, if you want to talk about a few topics, please reach out to me at Twitter. I'm reach at the Donnie Prakoso. That's my handler. And also connect with me on my LinkedIn, and I'll be more than glad to jump into discussion with all of you and answering all of your questions. So that's me. And then quick announcement. So for the a few past months, I've been brewing like a platform. This is an education platform. It's a short video courses that really crafted to help you get started with cloud technologies. So I call this a slide script, and you can access the website at this one. This is actually my first course. This is the building serverless API with AWS CDK and AWS Lambda, which is really relevant with what I'm going to present today. Jump in if you want to learn something new from serverless microservices to machine learning. Please go to this page. It's slidescript.dev, and then I'm currently brewing like a few another courses like microservices, event-driven architecture, and also visual analysis with Amazon Recognition. So that's the quick announcement. And this is the agenda for today. To give you a big picture, what we're going to talk about, we're going to start with the common business strategy, and we'll end up with the conclusion that actually the technology decisions drive your business strategy. So we're going to map from the business strategy into the technical discussion, technical roadmaps, and this is actually I think this is really common pitfall that sometimes most businesses they are unable to translate properly between business and also the technology strategy. So this is something that I would like to start and I want to share with you. And then moving on to the like a main cause of this talk is actually the question why serverless, why not some other technologies. So I'm going to describe why serverless is really a great fit, especially for startups and also the developers, because it removes any kind of frictions and also eliminates the need to maintain your resources. And moving on to the practical use cases, like I'm going to share like a few things that really fundamental that really helped me to shape my products before I joined AWS. And I believe this is something that really fundamental that I'm strongly believe in this kind of principles up until now. So I'm going to jump into slide and then also demos. So I hope you don't mind that I'm going to share my code screen. I'm going to show you how that we can deploy like a serverless API, how can we do like an infrastructure as code with AWS CDK, event driven, and many more. And then I'm going to end this talk with wrapping up with what kind of steps. What's the next step for you if you want to go into serverless universe and then you want to get started with serverless computing. So so these are the agenda that I've structured for today. And this talk actually inspired by Werner Vogels. Werner Vogels is a CTO of Amazon.com, and in one of his article, he mentioned something about serverless, and I just quote him here. Going serverless frees you to focus on activities that set your company apart, like product innovation. And I genuinely think that this is a truly an advantage of serverless because with serverless, it removes any kind of friction. It eliminates any needs to maintain the resources, maintain the operations, which they don't directly affect our business. Right? So they are not core of the business. And by focusing our time and giving a lot of effort on building the products, it gives a lot like values into your products, and you can pass the values to your customers. So this article is really interesting. I'm going to drop the links after the session, and because I really recommend you to read this article because it's so insightful. And then moving on, that we usually, when it comes to serverless, when it comes to modern digital business, there's always a word of transformation. So before we go into the transformation discussion, we need to step back and we need to understand what define modern digital business. So these there are five characteristics of modern digital business. The first one is customer obsessed. If you can see my cursor, I'm going to start from the left to the right. So the first one is customer obsessed. That means that we are trying to create a frictionless, immersive, and consistent experience to our customers across multiple channels. Like for example, we are trying to get their feedback and trying to build the features that actually our customers need that kind of features. And the next one is the organized for value. So this is where the leadership kicks in. Like when the leadership team they align with the funding and structure around discrete business outcomes. Like, and then on the third characters is test and learn. At Amazon and also at AWS, we always mention that it's always day one for everyone. So with by embracing that kind of characteristic, we acknowledge ourselves that this is a never-ending journey that we keep on learning and learning, testing, building the features, getting the feedback, and that kind of flywheels is actually what drive innovation. So this is a culture side that the learning organization they're focusing on experimentation, creating testing hypotheses, and then building the features into your products, and then release the products, getting the feedback. It's like an innovation flywheel. So that's how the cycle goes. And the fourth is the technology at the core. So by adopting technology, we understand that technology actually helps to drive the business strategy. And that it doesn't necessarily mean that you're going to become the technology company, but you leverage the technology to help you to achieve the business outcomes. And then the last one will be data. So data is a core asset and used in all decision making, easily accessible. So in these modern businesses, we've seen a lot of unstructured data, and um, we don't limit ourselves that if our technology or database that we cannot process that, we cannot accept that. So we need to be really understand that we need to capture any data that we have, and then to process to record information for our business needs. So these are the five characteristics of modern digital businesses, and this is also the same principles that has been used by our customers on how they move forward, how they grow globally, really by building a really highly available system. And talking about the transformation, I just want to give you illustration on what is transformation all about. So transformation is all about journey. So for example, that for the customer obsession level, you are in a specific point, and then you want to get us on a specific points. So this is the journey of digital fluency. And so just to give you a big picture on what transformation is all about, is just moving from one state to another state, which is going to give you a better situation, give you a better system, well informed, and so on and so on. And modern applications that we have already discussed about the characteristic of modern digital business. And when we translate it into the technology decisions, we can also characterize along five factors. So the first one is architectural patterns. So by building a modular services, it helps to ensure that our system is resilient, is highly scalable, and it still serves what our customer needs. And the next one is operational model, and this is where serverless kicks in. Right. So the operational model also means that if you can delegate that kind of mundane task or mundane operation in your development, you need to offload it to something else. Like for example, AWS as a cloud computing provider. The reason why, because if we have time that we can allocate to focus on the building applications, we need to focus on that kind of part, and we cannot create something, or we cannot still doing something that doesn't really direct into the business. So that's the idea of the operational model. So just to give you to free up your time and also your effort and focus on your building application. And so what is the software delivery? And this is actually really relates on the architectural patterns, because in your journey building a highly available system, you will end up by building a distributed system. You can call it like a distributed monolith. You can call it like a microservices. You can call it SOA. But the fact is that building the distributed system is actually the way that we need to go when we want to scale our system. And by having a lot of services and independent services in our system, so that means that we need to rethink about the software delivery. So this is why the software delivery is also important in the technology decisions, because we want to make them automated as possible, and we want to make them as standardized as possible. So imagine that you have like a 100 services that it's really doesn't make sense if you need to log in into SSH one by one, right? So you need to create a code pipeline. So you need to create a delivery pipeline from the development team to staging to UAT to production. And the fourth characteristic is the management and governance. So at Amazon, at AWS as well, that we always say that security is our utmost priority. So talking about security management and also the governance is everyone's responsibility. So it's not about the ops team responsibility, it's not the developer team's responsibility, it's everyone's responsibility, that we need to think about how we manage and also the governance our system. And the last one would be the data management. So I mentioned earlier talking about the databases, and we need to embrace that. There's a lot of data out there. There's a lot of growing data, especially in this era. And then that means that we cannot stick only with tools that we know. So, for example, if you are really confident with RDBMS, it's probably time that you might think that probably you need to use another database. So for example, like a NoSQL, or even like a time series database. So at AWS, we always mention that we providing tools for you for customers, for developers, that you can use this kind of tools for a purpose-built operation. And the next one is we're talking about the serverless business strategy. So you might wondering, so what is actually serverless? There's a lot of definition out there on the internet talking about serverless. So I don't want to jump into, oops, sorry, I don't want to jump and then introduce another definition. But I always love to think about the characteristic of serverless. Why? Because this is something that we can agree upon. So the first one, when we talk about serverless, that means that there's no server management. And when it comes there be no server management, that means that you are being freed up from your time, from your effort on managing your service, and you can focus on your applications, right? So that's amazing. And then also that you pay for value, like most of the serverless service, they have a really specific pricing model that you only pay for any kind of things that you use. And the third one is the flexible and also automated scaling. Okay, so this is something that I haven't seen, right? So for in my earlier working experience, that scaling application is something that's really hard to do. That we need to create a load balancer, right? And then we need to create application in the colocation, and then we need to create multiple containers and also VMs. It's just too many things to do. And with serverless, it eliminates all of those. So with serverless, especially like for example, AWS Lambda and also AWS Fargate, which is the computing offerings from AWS, you don't need to actually manage manually for the scaling. It's going to automatically scale for you. And because we're relying on the AWS infrastructures, there's a guarantee that it's going to be automated for high availability. So what does that mean? So that means that by adopting the serverless first mindset, it gives you really flexible opportunity to make a focus on your development for your products and not doing something that's not directly into it's not affecting your core business. For example, managing your servers, like doing patching, upgrading, maintaining the firewall, that doesn't necessarily direct to affect your core business, right? So that's what serverless means, that all these serverless services from AWS that we are trying and we are configuring as much as we can to help you to abstract away all those complexities, and you can use it right away. Okay, so and then when it comes to serverless, the common question that I frequently asked by people is that, so serverless is all about AWS Lambda? Not really. So I just want to clear out the misconception here that serverless is more than compute. So AWS Lambda is part of it. So AWS Lambda, for you might not really familiar with it. So AWS Lambda is a function as a service coming from AWS, which you can run your function in the cloud without running or managing any service. So that's good. And when it comes to serverless, it's actually more than AWS Lambda. Like for example, this one is only give you to like a quick diagram. Actually, there's a lot of services that I haven't included in this deck. Starting from compute, that we have AWS Lambda. And if you prefer to use containerization, containerize your application, you can use AWS Fargate. With AWS Fargate, you can deploy your containerized applications and let it scale automatically. So that's good, right? And then talking about data stores, Amazon S3 is one of my favorite service. I love it. I upload almost everything there for backup, and also like for example, when I'm doing like a machine learning research, and then I'm going just to upload all the data that I have on Amazon S3. And I just love to think about that. This is like really a peace of mind that having something that will not break. So it's really I'm really confident on building stuff. And for example, like if you want to run this like you need to deploy like a NoSQL database, or your application needs a specific needs in on the NoSQL operations, you can use Amazon DynamoDB. So Amazon DynamoDB is one the offering from AWS that will give you really flexibility on the NoSQL operations. And also, if you want to use the serverless, you can use Amazon Aurora Serverless, which is compatible to MySQL. So these are the one of example of that to give you a really understanding that serverless is more than compute. Serverless is more than AWS Lambda. There's a lot of thing, a lot of services that's going on that are being provided by AWS that will give you really flexibility on choosing what kind of problems to solve, what kind of problems that you have, and then you can deploy it right away with AWS. Okay, so this is the main course that I'm going to discuss about. So the first one, the practical use cases of serverless is first is moving to microservices. So more and more customers on AWS they are moving to microservices. So the reason because there's a lot of reasons. I just want to share with you the big difference between monolithic application and also the microservices. So in monolithic application that we put everything into one large single code base, and we by having one large code base, when we deploy it, we need to deploy it as a whole, right? And then and it becomes a problem when you need to scale, because when you need to scale your application, you need to scale, you need to replicate and deploy the entire application. And then when there's a problem in one of your code, that means it's going to break all of your applications. So this is one of the biggest challenges in monolithic, and that's why that we move to microservices. So the way I love to think about microservices is actually that we need to pull out of the function or services on monolithic and then create one service that do one thing well. So for example, if you are creating like an e-commerce applications, that means that it has like order service or payment service. You pull just pull it out and create a one service. So you need to define the boundary. You need to define the domain of your service, and you create the service, right? And then that means that this one specific business logic in one specific domain, it's they are independent. That means that you can deploy it and you can scale it as much as you need. And then that means that if something problems, like if one application has a problem, it will affect the others. Right? So that gives you really flexibility on identifying which service that you need to React whenever it has a problem. It gives you like a really good isolation, so it will not break the entire system. So this is why one of the reasons why microservices is being more popular. So and more or even that more and more people talking about the microservices. I just want to clear out the misconfusion that the microservices is complex. I would say that even though the microservices has a lot of patterns, a lot of like practices that you need to apply, uh, but most of the stuff is already been eliminated by serverless computing. So by combining serverless computing and also microservices, it gives you really flexibility that you can rapidly build your applications. It's going to give you a significant advantage of your development, and then you can still deploy it at scale. Right? So I would say that serverless microservices is really one good approach, and it's a really best practice for everyone, especially for startups that just getting started with their application. Okay, so the second thing that I like to share with all of you is that the APIs are the front door of modern applications. So in this world now that we are always trying to build a communication between one service to another service. So they are the front door of microservices, right? So with the modern applications and also with serverless, it gives you really flexibility that you can create a function with AWS Lambda, and you can integrate with Amazon API Gateway, and you get the endpoint. Right? And this is the typical infrastructure that we usually deploy when it comes to building a serverless API. So on the left side, you can see that we have clients, we have mobile applications, we have websites, we can have IoT as well, and they are connected to the internet. And when it connected to the internet, you can see my cursor around here. This is the Amazon API Gateway. So with Amazon API Gateway, it helps you to centralize the all those endpoint paths for your application while still giving you really powerful features when it comes to API operations. Like for example, that you don't need to worry about the DDoS because it has a built-in security in the Amazon API Gateway. And then you can also create an usage plan, means that you can create like pricing for your APIs if you have that specific needs. And it also integrate with the authentication and also the authorization platform that we have, like Amazon Cognito. Or you can even build on your own. You can create a Lambda custom authorizer, and from there you can connect to any kind of database. You can use the RDBMS, you can use DynamoDB, or you can even call the other services, right? So in my experience, that building serverless APIs nowadays is really robust. It's really simple. You don't need to worry no more about how to load balance, how to do like a scaling, because everything's already been done automatically by Amazon API Gateway and AWS Lambda. All right, so let's move to the demo. Okay, so I just want to show you about how it looks like. This is the AWS Lambda dashboard. You can see that I have a lot of function here. I just want to show it to you guys how easy it is to create serverless API. So let me create a function. So I'm going to name it Fast Tech API. And then I'm going to use like a Python. You can use like you can choose any kind of runtime that you want. For example, you can write Lambda function in Go, Java, Node.js, or Ruby, or you can even create a custom runtime you can run on your own. So I'm going to use Python here, and then I'm going to create a function. So in this point, we're going to integrate our AWS Lambda with API gateway. So I'm going to create an HTTP API. So it's going to be really simple one. So this is the API gateway dashboard. Um, Now we have AWS Lambda function. You can see that this is the code that we have. This is like a really simple. It just returns the status code and also the body, which is a JSON format, saying that hello from Lambda. So that's it, right? So what I'm going to do next, I'm going to add trigger. So I'm going to add trigger here. I'm going to create the API gateway, right? And then I'm going to create an API, and then I'm going to make it open because this is a demo. I'm going to delete afterwards. And then, yeah, I'm then going to add it. So what it's currently doing is actually trying to integrate our Lambda function and also the Amazon API gateway to create an endpoint. So once that is done, we can see here that everything is done, and then we have this endpoint. It is awesome. And then we can open this one, and there you go. So you can see that it's within 5 minutes when you want to deploy an API right now. It's so much different on previously when we didn't have any kind of serverless computing, right? So that's one demo. Like another demo that I want to show it to you that's it's actually really easy if you can automate the code for your serverless API. So for example, let me open my diagram. Okay, this one. So I hope you can see my diagram here. I'm not sure if it's too small or not. Okay, so imagine that you are building an application, right? You're building an e-commerce application, and you need to build like a serverless API. So, for example, we need to manage the order surface. You need to create the invoice surface to send an invoice to your customers, and then you need to create the fulfillment surface and also forecasting surface for your finance department. Right? So we have everything here, right? We need to create one Amazon API gateway, and then it's going to go to the order surface, and then it's going the other service is going to call invoice service, fulfillment service, and forecasting service. So this is only for an illustration only. This is actually coming from my event driven architecture talk, but I really do think it applies in this talk as well. So let me show you how it looks like. For example, okay, before we go there, I just want to show you that the tools that I'm going to use is called AWS CDK. It stands for Cloud Development Kit. So with CDK, you can define cloud infrastructure using familiar programming language. So you can use Python, you can use TypeScript to define your application. So I'm going to show you how it looks like. I hope it's not too small. I already enlarged the font. Sorry. And So I'm opening my code editor now, and I just want to show you how it looks like. The first one is that you need to create a Lambda function, right? So this lambda function, this is the configuration that I only need to create one lambda function. And then, so it says that this application is going to retrieve everything inside the folder of sa-lambda in voice service. And then replicate the configuration with the other lambda functions. And then I only need to create this simple lines to create an API gateway. So that means that I need to integrate this API with this lambda to handle the order service. And then add the resource API and add method get, as this is HTTP get method, to integrate with that lambda, right? So if I go here and I just I'm going to do like a difference just to see what's the difference between my current state. There were no difference, but we can actually deploy it as well. Right? So let's try to deploy it. So here's the real research on when you executing the CDK. So here that you have this endpoint, right? And then I almost forgot the resource that I use. API. So if we go um, to the browser and then we just put here. Yep. So there you go. Now you have like a full running APIs running in no time by using AWS CDK. And if you don't need it anymore, then you can just do the CDK destroy. Like you just delete it, right? Just like, let me give you an example. Let me delete it, and it's now currently destroying. So once that you've done with your API and then you don't need it anymore, you can easily destroy it with the CDK destroy. And if you want to deploy it again, you just use the CDK deploy. So it's pretty awesome. Yeah, so that's the demo on the modern API development, right? The next topic that I would like to share with all of you is talking about the data. So decoupling data strategy is actually improve the fault tolerance. Like for example, this is example of monolithic database, right? So in monolithic database, we have a single source of truth, which is for the microservices in the application. Now, the biggest problem with this that it gives you really like a bottleneck when it comes to like a blocking on the read and write into one single record. And then in the worst case is what happens if your database went down. Right? So we didn't want that, but if that happens, that means the whole your application is down. Now in the microservices universe, that you can decouple your data into each service to improve resilience. Like this is really a common approach, and I can think this is a best practice because if one service they have one database that they can do the like a query, or they can like create a record or retrieve the record based on that specific domains on the service, right? So this is you can use Amazon DynamoDB if you're going to the NoSQL operations. If you have something that related to the RDBMS, you can use the Amazon Aurora or Amazon RDS. So just to make sure that you need to embrace, you need to understand that you need to use a different database for different jobs. And the next thing is these events. So this is something that I really love to discuss because it's really help us to scale our applications. And events are actually the connectivity. It integrates between one service and another service. So when there's a changes in events, like a change in state or change any kind of updates on database, it's going to automatically send an event to notify any services that subscribe into specific event. So this means that with this kind of architecture, we can easily like have our services react and then deliver the business value without being asked. So this is really different with the synchronous communications that we usually use with HTTP REST API, and this is actually a really great move. If you want to move to event driven architecture, you also need to think about how to restructure your application to use asynchronous communication. So, event-driven architectures drive reliability and scalability. In the event-driven architectures, we know there are a few terminologies that we need to understand. The first one is event routers. So, in the event-driven architecture, there are three kind of components. There we have the event producer, we have event consumer, and also the event routers. So, event producers they emit the events, and the event consumers they consume the event. So, and the biggest challenge goes into the event routers because it's going to accept a lot of events coming from different services and it's going to need to fan out to specific services. So event routers, it helps to abstract producers and consumers from each other, right? And then I mentioned about this earlier about the asynchronous events that by having your applications running in asynchronous communication, it really helps responsiveness and also reduce dependencies. And it is also give you a great way to scale your application. And the last one is the event source that we need to buffer message until services are available to process. Okay, so these are the three terminologies that usually that we use when it comes to event-driven architecture. And there are several ways on doing this. AWS give you a lot of flexibility on how to build stuff. You can use the integration with Amazon SQS, and you can also integrate with Amazon SNS to do a fan out like a pops up. But and then you can also use Amazon Event Bridge, which is the service that I'm going to talk in this section. So Amazon Event Bridge is the serverless event bus service for AWS services, or even if you have like your or you like want to integrate with SaaS applications, it's really an easy way to integrate with your application. So why I love Event Bridge because it removes the friction of writing like a point-to-point integrations. So you don't need to create like a rules. You don't need to create like a how to route this specific event to specific service. Everything is already being managed by Amazon Event Bridge. So it abstract away the complexity of writing the point-to-point integrations. So you all you need to do is you can create the rules, and then you need to define the target, and then you just let your event producers to emit the events as going to direct the routes to the proper services. Another thing when it comes to event-driven architecture, then this is really a good food for thought for you if you want to apply the event-driven architecture. That you really need to understand that if in your system there's already like a lot of services, like for example, if you're building on AWS, there's a lot of events available for you to use. Like for example, if you upload your files into Amazon S3, it's going to automatically trigger like a notification to any kind of targets that you've defined. Like, hey, somebody just uploaded into my bucket. So what do you want me to do with this? Let me pass you the information. And another example, if you use DynamoDB, that you can react quickly whenever somebody upload or just add or insert a new row into your DynamoDB table. Right. So and then it's simple. It's as simple as that. And if you utilize that kind of events, that you have a really responsive system. And and another thing is that it's really simple to use Amazon Event Bridge because it provides you a simple programming model. With a few lines, you have your applications emit the events to Amazon Event Bridge. Oh, we go to serverless now. I will go to the demo. So let me show you how the event bridge looks like. Like for example, um, let me open the event bridge. This one. So okay, so here we go. So like for example, that that your system evolved, and now you have a really sophisticated system that, and then you think that I think this is a time to apply event-driven architecture. So continuing from the last demo that I showed to you, that we have an order surface. But the twist here now is that this order surface is going to publish an event called order created to Amazon Event Bridge. Now, this Amazon Event Bridge is going to like a fan out to invoice service. It's going to go to the fulfillment service, and it's going to publish the event to forecasting service. Okay. The another thing is that once the fulfillment service process the request, is going to emit another event called fulfillment completed, and then this event is going to be consumed by logistics service. And to give you like a real to illustrate a real life traffic, I'm going to put some delay from fulfillment service to the logistics service. Okay, so let me show you the demo. So I'm going to go to my next demo. Um, and then, oh, I think I've already done that. Artillery. So I'm going to use this one. Okay, so I'm going to run this. Yeah. So whenever I run this command, it's going to simulate like a traffic, like a 100 traffic to my backend, and then it's going to emit the events, and we can see it everything happening on this page. Right. So now it's starting. So it's going to like simulate the like the application like what you see right now. So the order service is received the request and is going to pass the invoice service, and then the invoice service is going to go to the fulfillment completed, and then the fulfillment service is going to notify the shipping service to inform that hey, this items is ready to package and deliver to customers. So this is one example on how event-driven architecture works, right? And if you see here, you know that this invoice service, fulfillment service, forecasting service, and logistics service, they don't know each other. So they have been abstracted away by Amazon Event Bridge, and it's really a good way because one service is not coupled to another service. And what does that mean? That means it's going to give you a great availability and also an easy way to scale your system. So just want to show you how it looks like. This is the Amazon Event Bridge. So I mentioned about that if you have like if you can also use Amazon Event Bridge to integrate with your SaaS application. For example, I want to show you like a few things a few partners that you can integrate with Amazon Event Bridge. You can have Zendesk, PagerDuty, Datadog, Whisper, and more. So, and then you can go to the Amazon Event Bridge and you can see the steps that you need to do when you want to integrate with the SaaS application. So that's a quick demo on Amazon Event Bridge. And I really recommend Event Bridge if you're just getting started with event-driven architecture because it's really frictionless. It really helps you to get started easily. Okay, so another thing is about the workflow orchestration, which is something that I love to talk about. The reason why, because more and more that I think that whenever our system process a request, it's actually there are multiple requests that it needs to be completed to fulfill the actual workflow. And when if you have already implemented this asynchronous communication, doing the workflow orchestration is so easy and so simple with AWS Step Functions. So for example, this is one diagram that I created to extract an image metadata once that I've uploaded an image to my Amazon S3 bucket. So with AWS Step Functions, you have this ability to control the state of of your system of your applications, and then you can have like an AWS Lambda or even AWS Fargate or even your long polling running applications to perform these tasks. So what does that mean? That if you remember that whenever that you create a flow in your application, like you have like a if, else if, or you can use switch, that you don't need to do that anymore. But because with the step function, that you can easily define the workflow one by one. Like for example, we have this step function started with extract image metadata, and then it's going to check the image type. If the image type is supported, then it's going to create a job status. So it has the ability by having a decision, and then you can also create a parallel job. Like for example, after it created the check job status, it's going to send to the Amazon recognition and also going to create a thumbnail, right? So this is a really powerful way on building an application, and it helps you application scale because now you don't need to couple off your functions altogether, but you can use AWS Step Function for that. One customer's reference that I love to present is actually frame.io. So frame.io use step function as a media transcoding solutions. They run this media solution, and then they use that function to break down all the steps it requires to properly run the application. Oh, I do think that I have a demo for this. Let me show you. Okay, so the last demo that I want to show it to you is how we can use the serverless API with the Amazon Event Bridge, with the event-driven architecture, and also how to leverage AWS Step Function to orchestrate the business workflow. So, for example, I'm going to use Stripe in this case. So, for example, that you have your application, you have an e-commerce application using Stripe, and then you want to process like every sales or payment received on that day, you want to visualize it in your business intelligence application. So what I'm doing there is that I'm setting up the webhook request. So whenever the Stripe done any kind of payment, it's going to call the webhook endpoint in Amazon API Gateway. And then the Amazon API Gateway is going to call AWS Lambda, which is a webhook service, which this webhook service is going to emit an event going to Amazon Event Bridge, right? And then from there, this Amazon Event Bridge has this kind of rules that, hey, this call is coming from Stripe with this specific type. What do you want me to do? So I'm going to call AWS Step Function for that. So this AWS Step Function, you can see here. This is the step function, the actual step function I'm going to use for this demo. So it's going to define the event type. So if the event type is payment, it's going to process the payment, it's going to upload to S3, and then we can visualize it with Amazon QuickSight, which is our business intelligence platform. So that's how it works. Let me show you how I'm going to do that. So this is I'm on this Stripe console. So I'm going to send a test webhook, and then if I click here, it's going to emit an event. Sorry, it's going to call the webhook endpoint on Amazon API Gateway, and Amazon API Gateway we're going call to AWS Lambda. And if everything works well, we can see what's happening in this AWS Step function, right? So let's go to the event bridge demo and we can try. Okay, so here's the latest one, which is 21st June, 7:46. This is on my Singapore time zone. You can see here, like, nice, everything's is in green, means everything's successfully carried out by the specific task. So it received the event type, which is the payment process, and then it's going to process the payment with this kind of input, and it's going to upload to S3. And we can see the results here with Amazon QuickSight. So now you understand that by integrating serverless and then the event-driven architecture and also the orchestrating your workflow, you'll be able to create really agile development and also highly available system with really responsive system that will suit your business needs. So everything that I share with you is actually the story of the development transformation at Amazon around 2001 and 2002. So the lesson is learned. They need to decompose for agility. They moved from the monolithic applications and a lot of teams, and then they moved to microservices and also to pizza teams and use serverless along the way. And with by adopting this kind of practices, they are able to deploy like a more than 60 million deployments a year. That's massive. I don't want to I just want to share with you that this is kind of state that you can actually achieve whenever that you choose a right technology stack for you. In this case, it's serverless. So we are witnessing a paradigm shift, right? So like what is stated in this section is that 75% of organization use or plan to use serverless technology within the next 2 years. So focus on your business logic. You need to experiment, innovate more often. You need to release feature faster, and you can build the better products. And all of these kind of best practices is it only has one objective, which is to give a great value for your customers. And lastly, so what are your first steps? The first steps that you need to do is that you find your serverless developers today. You don't need to worry about this because with serverless everything is really simple. You can use like a multiple language, so you can use Node.js, you can use Python, you can Go, you can use your own custom runtime. And once that you have your serverless developers, you need to create a team that really proficient in serverless computing. So they will be able to translate all these business needs into technology roadmaps. And then lastly, that you probably want to create a lighthouse project, which is a really simple project just to get started with serverless. And then from there, you can easily move to really bigger workloads. So that's it. So that's my session. So happy for you to attend this session, and I think this is time we go to the Q&A session.
Yeah, so that was a really, really good session. And since we had a very good, demand for this session to happen
Hmm?
on the topic of serverless, we have a couple of questions, and we have like 10 minutes to answer these questions. So there's a question from Sonia. If you can see on your live section comment,
Oh yeah, I'm seeing it now.
I'm working on a platform to detect phrases from baby cry. It's a deep learning model, and I'm thinking to learn serverless and integrate it somehow to manage all the models. Is it a good
Mm.
approach?
I can okay. So the if you are building like a machine learning applications, it's a deep learning model means that you are creating your own applications. So what I would suggest is that you need to leverage on this Amazon SageMaker. Sorry. Yeah. So Amazon SageMakers is a really cool platform that I use daily to deploy the machine learning models that you can build, and the output is actually the inference model. Now, this inference model that you can actually trigger from your serverless application. So I would say that divide these applications. So you need to categorize the application you need to build on serverless, and then the machine learning part that you need to use Amazon SageMaker. And I can say that yes, this is a really good approach because it will save you cost and time because you don't need to build everything from the scratch.
Yeah. So there's another
Hmm.
question from Rubab. Is using CDK optional? Same operations can be done via AWS console as
Okay.
well.
Okay, so I love that questions. Thank you, Rupap. So it's not the question about optional or mandatory. It's about your preference. If you are building the microservices and you go to the console like building and then click on one surface and then you need to step by step clicking one, two, three. I don't think that's optimal, right? So all you need to do is that you need to create a way to automate all of this process. So you can use CDK, you can use AWS CloudFormation, you can use Terraform. But the my main point being is that if you can automate anything, please automate it because it will help you to scale and seamless the integration between development and operation.
Yeah. So there's another question from Danya. Hi, I'm working at
Hmm.
deep reinforcement model to predict stocks. I want to connect my model with
Okay.
Flutter application. My question is, which services and server architecture should I use to deploy my model in AWS?
Okay. So thank you, Daniel. So I just want to show it to you that, okay, I hope that you can see my screen now. I hope it's not too small. So this is a common architecture that I always advocate when building a serverless API. So the thing that you need to use first is the Amazon API gateway. Why? Because you need to have something to centralize your applications and manage all the endpoint path, and also to be to route the request to your AWS Lambda function. And for the operation, you can use AWS Lambda. So I really recommend you to use AWS Lambda because it will save you cost and also save you time building application. And that once that you have everything doing well, you can actually create like a casing mechanism using Amazon CloudFront and also API Gateway. Right. So this is the like really recommended application because what it says actually that you need to start small and then over time that you can grow bigger and bigger. But just to bear in mind, start small. It will give you like a flexibility and room without having a sophisticated system at first.
Yeah. So there's another question from Rubab
Hmm.
again. How does data sync between those databases happen in case of distributed databases?
Okay, so Okay, data synchronization. This is something a really important topic when it comes to like a distributed system or microservices, right? So there are a few ways on doing this. There are like two PC, or even you can use Saga pattern. So with the Saga pattern, then you can actually create a step by step, and then it will give you like a consistency whenever you want to do the rollback, right? So to do this, that's why I encourage you to take a look at step functions, because with AWS step function, and if you have like a replay event or like a event sourcing, you can easily replay all those events, and then you can roll back, or you can create the event from the first the events coming to your system. So the data synchronization is really one of important topic. And then when it comes to database, I really recommend you to take a look into Amazon DynamoDB. The reason why, because it's really easy to scale with Amazon DynamoDB while still giving you a flexibility on querying your data.
Yeah. So
Mm,
how to determine the cost of serverless services? I'm using
mm,
S3 Lambda API gateway, DynamoDB load balancer, and SNS.
mm.
Please
Okay.
answer.
So I'm not really clear in on the questions there, how to determine the cost of serverless services. Okay, so if you're actually looking for the pricing model for specific service, you can go to the specific service like AWS Lambda pricing. Like for example here, that we at AWS, they are always try to really transparent on the pricing model, and this is I think really good stuff for you. For example, like AWS Lambda, the free user tier includes like a 1 million free requests a month. So so yeah, so every service they have a different pricing structure, and I really recommend you to go to the its detail page.
Yeah. So actually, this live streaming is happening at different our different pages and our partners' pages, Facebook pages,
Hmm,
platforms. So there's a lot of questions at other Facebook pages as well where this live
okay.
stream is happening. So our team is trying to fetch some of those questions. There's another question from
Mhm.
Zishan. Is it a good practice to invest in serverless technologies before scaling requirement, or it is an overkill?
Okay, can you repeat that?
Yeah. So, is it a good practice to invest in serverless technologies
Okay.
before scaling requirements, or is it an overkill?
I do think it's a best technology to invest. Now, to understand about this, that you need to understand how hard it is to build your own infrastructure. So if you don't have any experience on running manually, like using the VM or running containers, and you don't have any teams to manage that, then I would say that serverless is your best bet. Why is serverless is really good way to get started with development, because all those complexities is will be removed away, and so you only need to use this kind of services. So I would say that serverless is really a good way with technology to invest. So start building your skills into your serverless just to create a simple application, because in the end what really matters is not the technology but how fast you deliver the value for your customers. That's the main objective.
Perfect. So, there's another question. Also, is there a managed time series data store in AWS?
Manage time series database. Oh, okay. So manage time series. So there's a few services that you can use for this. You can use that. That depends on your structure, right? So let me go to the my AWS console. I just to give you a flavor on the breadth and depth services from AWS. Like for example here. Oh, sorry. So database right here. So for database, we have the RDS, we have DynamoDB, we have the Elasticase, Neptune, Redshift, QLDB, DocumentDB, and Keyspaces. And that really depends on when you're building like a time series database. That really depends on actually if you really need that kind of needs to build the time series. And most of the times that I use DynamoDB to implement any kind of application that requires time series.
Yeah. So actually, this live stream is recorded, and it will be available at our Facebook pages.
Okay.
So all those people that will be watching this live session later on, they
Okay.
can they can ask those questions in the comment section, and later on, someone from our team can can collect those questions and deliver it to you, or maybe you can like drop your contact details or email, something like that, or AWS support.
Definitely.
Yeah.
I
So
love just drop your questions. I'll be more than glad and jump into discussions in the Facebook page.
yeah, for sure. So I guess we're run out of the time, and also there isn't any more questions in the comment section. So that's bring us to the end of the session. Thank you so much, Donnie, for your important time and such an informative session. It was equally informative. I hope it was equally informative for the audience as well. And thank you so much for the support from AWS, because we were doing this AWS series and we had three different events before the session as well. And we had technical events, we had events for startups, and from Kai, from Frank, and from another speaker. And it was really really amazing that you guys shared your time with us and honored us with your presence. Thank you so
Thank you
much.
for organizing Pack. Thank you, Hamza, for having me here, and all the best for all startups and developers out there. Thank you so much.
Yeah, thank you so much. Looking forward to host you over here in Pakistan
I'm
next
looking
time.
forward to do that.
Yeah, take
Okay.
care.
Okay. Bye, everyone.